Hello there guys, welcome back to another epic inexorable maths video. In this video we've got yet another video on double integration. So that's what we're going to do right now. We're going to do an example question and it's as follows. So there's a few things with this question that we've not really seen before. First of all, they give us the limits of the integration as just the letter R, which is a bit weird. Luckily, they do tell us what R is. It's defined by a region. It's the set of all x and y coordinates such that x is between 0 and 2.5, and y is between 0 and the square root of 1 minus x. Okay, cool. We've also got a little dA right there. dA, well, what's that? dA is just going to be dx dy or dy dx, but they've not told us which way around it is. So it's could be used in place of dy times dx or dx times dy. It just means an area, right? So that's all it is. It's just a small piece of area. A small piece of x and y makes a very, very, very small square or rectangle, and that's what dA is. So we can replace that in a moment with a dx and a dy in some order. Okay, so let's do it. Well, okay, well, first things first, the first thing that we need to do is write our double integral with some actual limits that can be evaluated. How do we do that? Well, what are they? I mean, sure, we've been given this region, but what do we do with it? Well, of course, we're told that x is between 0 and 1/2, so maybe we can draw it. Here's our x-axis, here's our y-axis. I always recommend drawing it, guys. X is between 0 and 1/2, so maybe 0 is here and 1/2 is about here. And y is between 0 and the square root of 1 minus x. Well, the square root of x is it's a kind of sideways parabola. Now, it's minus x, so it's kind of going to be going this way, and it's moved to the right by 1. If you can see that, then that's okay. I don't want to do a video on translating functions and stuff and reflecting them, but it will look like this, okay? Hopefully that makes sense. The original graph would be the same shape, but flipped in the y-axis, and it would also be going from 0, and it would kind of come up like that, if that makes sense. But that's the graph. Lovely. And this point here is the point 1. Hopefully that makes sense. Well, that's the graph there, and then x between 0 and 1/2. I'll draw the line x equals 1/2 for us. It looks a little bit like that. And it's between these two graphs. It needs to satisfy both. So what region on this graph satisfies both of those conditions? Well, it's going to be this region right here. Okay. And I'm going to label this y equals the square root of 1 minus x. And I'm going to label this x equals 1/2. Okay. Hopefully that's all good so far. Okay, so we want, again, as always, this is not the area that we're looking for. This is the area that we're integrating over. So we're not trying to find this area. But what we can do is we can go into our limits and we can actually substitute some stuff in now. So the question is, it will always be, the integrand doesn't change, so it's always 2xy or whatever it ends up being. And it's going to be a dx dy, but in an order that we don't know yet. So I'm just going to write d space, because it might be x then y, or it might be y then x. I don't know yet. Sometimes it matters, sometimes it doesn't, but it might matter. The hint is it's going to matter. So here's the question, guys. By looking at this, we want to either be integrating from left to right first, and then bottom to top, or we want to go from bottom to top first and then left to right. But the problem is there's one way around that won't work. You cannot go left to right first in this question. The reason is because if you go left to right, so we're integrating along this region left to right, what function stops our region from coming towards me, to the left? Well, it's just the line x equals 0, right? It's just this vertical line, x equals 0. That is the line that is stopping me. However, the line that is stopping this region go to the right, which, what is it? Well, it's x equals 1/2. Draw some arrows in to show you. x equals a half. This line here is stopping us. However, once we get up here, it's not x equals a half anymore that is stopping us. It's actually the square root of 1 minus x. And that's bad news. You don't want to be changing the function that you're being bounded by. So what we should do is we should go down to up first. Because what function stops us from going down? Well, it's just the line y equals 0, the x-axis, right? What stops us from going up to space? Well, it's just the square root of 1 minus x. There's no problems. And it always is, guys. If you draw vertical lines going up, it's always the same two functions that are bounding us. That's what we want. If we go left to right first, it will be different functions that are bounding us in different places. We do not want that. So we're going to integrate up to down first, which means this will be a dy. Because y means you're integrating down to up, okay? Right, now what will the limits be? Again, down to up, the lower bound is the line y equals 0, and the upper bound is the line y equals the square root of 1 minus x, or I should say the curve. So this will be y equals 0 and y equals the square root of 1 minus x. Okay, what about in the x direction? Now remember, guys, the integral on the outside, the leftmost integral, must always have constants in the limit, otherwise you will not get a constant in your final answer. So these need to be constants, so it should be easier. All that we need to do is figure out what constant value of x stops us going left and stops us going too far to the right. It's clearly just 0 and 1/2. So 0 and 1/2. So we've done our limits, now we can actually try to compute this. So as always, the first thing that we're going to do is we're going to come in, we're going to write our leftmost integral just how it was, and we're actually going to evaluate the internal integral. Now guys, we're integrating with respect to y, which means x is a constant. So this is 2 times a constant y being integrated. This will become x times y squared. Okay, hopefully that makes sense because we've done it respect to y. So if you differentiate this with respect to y, you would get 2xy, if x is a constant, which it is. So then the limits are, again, between 0 and the square root of 1 minus x. There's a dx on the outside, and then we work out what this is. So let me raise the board up slightly. Okay, so this is the integral from 0 to 1/2, and then we're substituting the square root of 1 minus x in where the y's are, and we're leaving the x's. So this is x times the square root of 1 minus x, but it's being squared because y is being squared. So it's actually just 1 minus x here. Okay, cool. Right, let's go on to a new board here, some space. So this is our integral, 0 to 1/2. It looks like it's from 0 to 0, but this 0 here is connected to the integral above. Okay. And then let's expand this out before we integrate it. So we'll get x times, or just x, sorry, minus x squared dx. And again, guys, this is just a simple integral. You can just do this fairly easily, hopefully. This will be 1/2 x squared minus 1/3 x cubed. And the limits are 0 and 1/2, so 0 to 1/2. And then you sub in, so you've got 1/2 times 1/2 squared minus 1/3 times 1/2 cubed. And there's a bunch of stuff that we're taking away, but you can see that it's all 0, right? It's 1/2 times 0 squared minus 1/3 times 0 cubed. So it's all 0, so I won't write it. Okay, this is an 1/8. This is an 1/8 times 1/3, so minus a 24th. An 1/8 is 3/24. So I'm going to replace this with 3 over 24. And 3 over 24 minus 1 over 24 is 2 over 24, which is 1 over 12, meaning the answer is a 12th. That's the value of the integral. So we can now say this guy here is equal to a 12th. Hopefully that makes sense, guys. Thank you so much for watching. I'll see you in the next video.